Hi there, this is Math 116, Section 5.2, more logarithms. What could be more fun than logarithms? More logarithms. So, in this section, or this video, I just wanted to go over more of the rules that are covered in this section. And unfortunately for you, one of the reasons you are required to take Math 116 for whatever reason, whatever program you're pursuing, whatever degree you are taking this class for, logarithms is one of the things that they want you to be familiar with. So because you've taken this class, people are going to assume that you are familiar with these rules. Rules like this. Log base A of A is equal to, this is a little rule, 1. Why is that, Kate? Well, it's because A, this would translate as A to the 1 equals, well, that's A. So that's, I would say obvious, but often things are not obvious when you are sitting alone in a test staring at them. And here's another rule. Log base A of 1 equals, what does that equal? 0. That is because A to the 0, anything to the 0, is 1. So this would look like this. Suppose you had a question that says log of 10 is equal to what? Well, remember log. Anytime you don't specify, that's log base 10. So that would be log base 10 of 10 is equal to 1, because these two match. They matchy. Matchy. Suppose you had natural log of 1 equals what? Yes, it equals 0, because the log base anything of 1 equals 0. And you can try this on your calculator. Type in natural log of 1. It's always nice to get stuck on a test. You can type it into your calculator. Okay, here's some more rules. You love rules. It adds order to your life. They actually call this rule number 3. And it's on, I don't know what page it's on. Oh, 345. There we go. So here's the rule. Natural log of m, where m is some number and n is some number, or they're things that are greater than 0. You can rewrite this. If it's the log and they're multiplied together, this is equal to the log of m plus the log of n. So you can take what's inside the parentheses if they're multiplied and split it out and add them together. So this would look like this. Suppose you had log base 10 of 7 times 11. Well, you could rewrite that as log of 7 plus log of 11. You're thinking, this doesn't help me out at all. I could take log of 77. That's no big deal. But for some problems where one of these is a variable, they will come in handy, and it's very handy in calculus. That was page. Okay, here's another property. This is the multiplication property. That means we have a division property. So if you have log of m divided by n, as in Nancy, that is equal to the subtraction of the logs, m minus log of n, as in November. So, suppose you had log of 7 divided by 11. Well, that is equal to log of 7 minus log of 11. All right, these rules, you probably want to write them down, but at some point, you know, someone will make some quick thing about logs in some future class, and they'll refer you to these rules, and you'll think, oh no, I wasn't paying attention. Those log rules, and then you'll remember. Okay, so here's an example of how this works. Suppose we have question number 35. This is what they write. They say log of x divided by x plus 1, and they want you to rewrite this. What exactly do they say it? As the sum or difference of two expressions. So, rewrite this. Well, this is a divided by, so we're in this situation because that's divided by. So we can rewrite this as log of x minus the log of what's on bottom, x plus 1. And we have to stop there. We can't split this out. So this is not equal to log of x plus log of 1 like that. No, no, don't even look at it. It's not true. This is your answer. Okay, here's another one. This is question number 39. Did you like that log song? Okay, we're doing the opposite now. They say, look at this problem. We have natural log of x minus natural log of y. So rewrite this one in terms of one logarithm. Well, we have a minus, so if you go back to these rules, now we're on this side, we have a minus, so we're going to rewrite it like that over here. So we can rewrite this one as natural log of x, and that one goes on the denominator, divided by y. Okay, and there's one more rule for you to look at, and I think they call this rule, actually no, there's two more rules. Sorry I lied about the rules. I think they call this rule 4. My pen's too skinny. Rule 4. It's the exponent rule. Some of you are thinking, exponents? I thought this was the log chapter. Well, you can have logs and exponents. We're that lucky. Log base a of m raised to some number n. So m has an exponent, n. We can rewrite this as n times log base a of m. Basically, you can bring this n down in front. So suppose you had, here's an example of what this looks like. If you have log base 3 of 9 squared, you can write that as 2 times log base 3 of 9. Alright? You're saying, but I wouldn't write it that way. I would never. I wouldn't care. Well, you would if you were doing problem number 37, which says we want to use these rules to rewrite this. Log base 7 of x times the cube root, draw a straight line, of x plus 4. Okay, so we're going to use two of the rules together. Let me draw a little line here to indicate that we are doing a separate problem. So the first thing I'm going to do is notice that this x is multiplied by this piece here. They're two multiplied together. So because they're multiplied, I can use the multiplied rule, see m times n, and I can split them up and add them. So that's the first thing I'm going to do. That's log base 7 of x plus log base 7 of, I'm going to write this as x plus 4 to the 1/3. Because cube root means this thing raised to the 1/3. And I'm not done yet. So now I'm going to take my exponent rule. Do you see how the 1/3 is up in this exponent? And now I can rewrite this whole thing as log base 7 of x, that's that piece, plus the 1/3 is going to go in front because of this logarithm property. It's an exponent, so it can be multiplied in front. So plus 1/3 times log base 7 of x plus 4. I'm running out of space. And that's your answer. So that is how you do those. So you should be able to answer some true-false question. Does this equal this? Yes. True. Like that. Okay. One more. I was like, I thought there was something else. There is more. This one is bizarro, but it's quite clever. Change of base formula. Here's the problem. Suppose you want to find, in your calculator, you have this problem. You're supposed to find log base 2 of 17. Right? And you actually are supposed to type in a number. Equals what? Well, here's the problem. You don't have a log base 2 on your calculator. Not on calculator. So you can get around this by using this change of base formula, which looks like this. I'll say it's yellow. This is on page 346. If you have the log base b of some function x, you can rewrite this as the log with some other base of x divided by the log of that same base. You can just pick a new base and do x divided by b. What? Okay, so if you have, for example, make a little example over here. If you have log base 5 of x, you can say, well, that's equal to the natural log of x divided by the natural log of 5, because the natural log is log base e. It could be some other base. What? Okay, let's try another one. How about this? Suppose we had log base 6 of 2. You could write that as log base 10 of 2. I'm just changing the base divided by log base 10 of 6. And that way you can do these on your calculator. The only reason to do the change of base formula is to change it to either, you're going to change it to natural log, which is base e, or you're going to change it to regular log, which is base 10. So it's no real reason that I can see to change it from base 8 to base 2 or something. But you never know. Life is full of surprises. You might find yourself doing this. Back to our problem. Log base 2 of 17. Okay. Well, you can take natural log. You can take, regular log, whatever. But I'll take natural log just to be different. We can say, rewrite this as natural log of 17 divided by natural log of 2. And now you can plug these both into your calculator. So you should get 2.833 for the top piece and about 0.69314, something like that, for the bottom piece. And your final answer should be 4.087-ish. That's your final answer. And you should get this whether or not you use natural log. You should also get the same answer using log base 10 of 17 divided by log base 10 of 2. I'm going to do it right now. Here's my calculator. Type. Okay. Log of 17 divided by log of 2. Yep, look at that. 4.07. I am so good. All right. Look at those logs.